Okay, so we have a MacBook Air. This is an A1466. We have already done assessment on the device. So the client wanted an assessment first, and then they had to decide if to go ahead with it or no. So they got back to say yes, we can go ahead with the repair. So pre-assessment that we did, we found a short on the PP bus well. So let me just open up the board view. So the pre-assessment that we did, this is a 2017 MacBook Air. So the board number is 80-00165, as you guys can see here. We did a pre-assessment on the board, and then we found a short on our PP bus rail, which we were able to easily identify on our fuse, which is a F7140. We are yet to narrow down where the short is coming from. So that's what we are going to do now. Now there are two ways we can narrow down this type of issue. But number one is we can isolate the issue. Both ways we have to isolate the issue by removing the fuse. Now, why do we need to do so? So because this is a fuse and it's a wire, so which means whatever you have on pin 1 is going to be equal to what you have on pin 2. Now, if we have a short on this side, it means you also have a short on this side, because whatever is connected here will also be connected here. If we, however, remove the fuse, now we can determine if the short is on pin 1 side of pin 1 or the side of pin 2. Now, if we remove the fuse, there are two ways we can go about it. So, say for example, what we are going to do now is we are going to remove the fuse. After the fuse is removed, we will now measure to see if our short is on the side of. So if I click on pin 1, it gives me all of the components that are connected to the side of pin 1. Now, if any of these components here are shorted to ground, it will affect the components on the other side as well because of the fuse. Now, if I click on this other side, you will see the components that are connected on the other side. So when we need to remove the fuse. So I said there are two ways we can solve this. We can remove the fuse and start to manually remove the components that are connected to the line one by one, or we can remove the fuse and inject voltage on the line. When we inject voltage, whatever components that power is passing through to ground will get warm. So that will identify that is where the problem lies. So, but we are not going to do that. We're going to use the manual option. We're not going to inject voltage. We're just going to randomly remove the components that are on the line, not random, but remove the components that are sitting on the line to see where, which of, and an issue like this one is very typical that most likely it's a failed capacitor. Yes, most likely it's a failed capacitor. So what you are now going to do is, like I said, the board is already out. Uh, so, and also she had like a swollen battery, which I did mention to her, but I mean, that's not primarily the issue at the moment, because with or without the battery, with a charger, the device is still going to work. So she is aware of that. We just need to, so I'm just going to show you guys what I'm talking about. Now, this is the fuse I was referring to here. This one here, that's the fuse I was referring to. Now, if we measure on the fuse, that one of the way you can confirm the health of a fuse is by checking if you have continuity on both sides. I have continuity on both sides, which tells me that the fuse is fine. Now, if I place my black probe to ground, a screw hole, and then my red probe, I place it on the fuse, I get a beep, and that is because a component that is connected to that line is shorted to ground. So what we are now going to do is to remove the fuse and see which side of the board we have the short. So let's remove the Wi-Fi card. Uh, uh, do you understand you understand the concept? Yes. So this is more like a wire on its own. Now, whatever is on this side, if this is shorted to ground, if this is by short, it means that this line is connected to ground, which is not supposed to be. Now, if it's connected to ground, anything that goes on that line will go to ground. So what we want to find out is which component that is connected to that line that is making its way to, that is causing the line to go to ground. So when we remove this fuse, like I explained, one side feeds one, and then the other side face the other side. So if we remove it, now we can tell which side is the short coming from. Okay, that is out. Now we are now going to so when I'm working on the board, with the board, you need to be close to the board. Whether I am busy or not, you need to be close to the board now. The only time you kind of move a little bit backward is if you need to also see what you have on your multimeter. But beyond that, you have to be focused on the board. So now we want to see if our short is on this side or on this side. So black blue on ground, and then red pearl. Let's check this side first. Our short is not on that side, and then this side. So our short is on the side. So our short is on the section of the pin 2. So this we have the short is not on this side. So which then means that we are not going to worry about these components here now because we don't have a short here. Now the short is on this side of the board. Now on this side of the board we have a current sensing resistor. Now this current sensing resistor, the way it's going to work, come I'll show you that now. So there are two. We have one R5430, which is R5430 is not populated. It means it's not on the board. And then we have R5450. It's on the board. Now the way this is going to work is this is a current sensing resistor. This has four almost equal sides, which is 1, 2, 3, 3, and 4. Now whatever it's going to be on pin 2 is going to be equal to what you have on pin 1. Now what that means is if you see here, the components that are connected to pin 2 are not that much. It's just this, and then you have this, and then you have the fuse. But I can tell you that this is not going to be our problem. Our problem is most likely going to be either in this area, these capacitors here, or the capacitors here. Sometimes you may also find that these capacitors here will fail. Now we know this is definitely not the problem. We know this is definitely not the problem. Now our problem is now we now need to click on this, which is now going to take us to this section. So when we click on this, we see now that our issue is going to be either this section here or this section. Now how do we isolate that? So we know from this point to this point, we know we have a short. To confirm if our short has to do from this point forward, we need to remove this. If we remove this, then it means there is no longer connection between pin 1 and pin 2 on this line. So it means this line will no longer be connected. So let's remove that. So like I said, we are going to use we are only going to use the manual option. No. Yes, you can bend the camera. You can't. No, you can't. So I'm not getting quite a view. Yeah, but then you change your view because if you bend it, you screw the image. Okay, now that resistor is out. Now we want to confirm if we still have a short on this line here. And you see now the short is gone. Do you understand? Yeah. So what we have successfully done now is we confirmed that our short is not here. We've confirmed that our short is not on this line. Now our problem is going to now if you see our problem is going to be from this line forward, from this line forward. Now, the reason why we having a short on PP bus 9 is because of R54 5450 that has a communication with the line of your PP bus. With this out of the line, we no longer have PP bus is no longer having any type of communication with the other section of R5450. So we can now safely put back the fuse. So we know that is not our problem. We can now put back the fuse and then continue forward. Okay, the fuse is installed. Now we know that definitely our problem is neither here nor here. So you will notice that this section here, that's where the short is. You don't have a short here, the short is here. Now this and this was reading as one because of the resistor here, because pin one with this resistor, pin one is going to be what is going to be equal to pin two. You understand? Slight, there's a slight difference in terms of voltage. Okay, that's something else. But basically, with this resistor installed, pin one will automatically become almost equal to pin two. Now, so we know now that our problem is going to be either this region here or the region by the CPU. So what we want to do is we want to inspect this section here to see if any of these caps, if there is any type of burnt mark or any mark that would suggest that any of these caps have failed. So let's start from this section first, which is going to be this section here. So this, we don't see anything here, and none of this MOSFETs do we see that looks to have any issue, which then mean that we may have issue down the side. So let us if nothing stands out, we have to remove all of the caps. Oh yeah, okay, we actually found the culprit. So I'm not sure if you guys can see that, but there is a burnt mark on this cap here. Can you see it? Can you see it? Yeah, so that there's a burnt mark there. So that is definitely why we have a short. So I'm just going to remove the fan, even though we don't really have to do that. Let's not be need to remove the fan. So we can easily remove that cap. So let's remove the cap. So that guy there. One way we could also do it, if we didn't see the burnt mark, we could remove all of the caps in that section. Yeah. Okay. The cap is out. This is a tantalum capacitor. Now we can that tantalum capacitor. It doesn't have to be board specific. You can grab it from anywhere, and you are good. This is an 11 inches. We are gonna grab it from an 11 inches, so almost the same area. Now this is a tantalum capacitor, and it is also polarized. By polarized, it means it has to work on a particular polarity. So you have to be aware of what is your main and what is your ground. So a polarized capacitor is basically that capacitor that you have to be aware of the orientation of it. Unlike the non-polarized, that you don't have to worry about. You don't have to worry about the orientation. So now I suppose this is orienting that way. Let's just confirm that. So this is the guy that burned out. This guy here. Yeah, that's it. So if we flip the board to ourselves. Yes, so this is the guy C70, C7372 is the guy that burnt out. So which is which means our, so here You see that line? You see that line? That is your main. That is what is going to represent your main. And then the other side will be ground. So you don't flip it the other way. No, it has to be like this. So that is the difference between a polarized and the non-polarized capacitor. If it was non-polarized, you don't have to worry. It means it is whatever direction you place it, you are good.
So even though they might look the same, they serve a different task.
No, all of these are the same. The capacitors here, they are all the same. So now that is there. Let's now put back our current sensor resistor as well. Remember before we were having a short on that line, so we are now just going to confirm that we no longer have a short on that line. So our black probe is on ground, and then our red probe, and we used to, I mean, before now we will get a beep which will tell us that we are connected to ground. So when we place this on a ground hole, and then we place this on the line, it would beep to say that they are both on the same plane. Do you understand? Because if I join them, it beeps. Now if I place this here, and then I place this on another screw hole, it will beep because it simply means I am on the same plane. Now, if I place it here, before it was beeping, which was the reason why it was beeping was because this line was connected to ground because of the cap that failed. Now that the cap is no longer there, the short is gone. Okay, we can now put back. So you see, in this case, we didn't have to use any type of voltage injection method to fix it. So it was all manual.
Is it more effective than the other?
The other is quicker, but this is handy in place where, especially if you don't have, if you don't have a power supply to inject voltage. This is, I mean, you at least you can use this. You don't the option of the power supply. It's more handy, and but then again, you need to know how to use it because you don't want to send too much power onto your line, and that line, it's a line you don't want to basically send too much power in because of your CPU. Is it There's an extension of the CPU. Okay. So now, all of this time while we were doing our troubleshooting, we didn't connect power to it. We did not plug power to the board. And it's always not, only when you confirm that it is safe to connect power to your board, only then should you connect power to your board. But until then, don't connect power to the board. Okay, now that is done, we now need yes, now we now need to put power to the board. The LED will not be present because we don't have the I/O board cable. Sure.
So we're not getting the LED.
Yes, because there will be no because of the I/O board cable not being present. So that's a and then or something else also, we are not getting power, so most likely our DC jack is faulty. So let's just get another DC jack. Okay, we still don't have power. Let's see what is going on. We have PPDC in voltage. We have PPDC in voltage. Do we have PP bus? We have PP bus voltage, and then on the other side, uh, okay, let me see. What's going on? One side we have 8.5, and then the other side we have less than that. So it seems the fuse is blown, but then what I don't understand is, do we still have a short on that side? I mean, we measured the first time and the fuse was fine. So how is it that the, so let's see. Do we have a short back? No, we don't have a short and the fuse. Interesting. Even though the fuse is not blown, but okay. Let's replace it. Can use this one. It may just be that we have a secondary problem with it, but let's just go ahead and replace it. And if we have the same problem, then we find out why that is the case. Okay, let's give it a bit of time to cool off. Okay, let's check the fuse again. Let's check this one that we installed. Fuse is fine. Let's put power to it. Now, by the way, whenever I am troubleshooting a board, I tend not to. I like to have the fan disconnected because I don't really want to see. I don't want to wait on the fan spinning because it kind of gives you anxiety. You kind of you just want to see the fan spin. So what I usually do is I would disconnect the fan. I'll let my multimeter tell me what is going on the board, and then if my multimeter tells me my board is on, then I can plug the fan. So let's do that. disconnect the DC jack. Obviously, we're not expecting to see a fan spin because the fan is not connected. We want to see what we have on both sides of the PP bus fuse. One side we have 8.5, which is good, and then the other side, what do we have? 8.5. So definitely our fuse was fine. Was a problem. Do you understand now? So initially, remember we would have there was 8.5 here, and there was 4 and 3 volt on the other side. But now we have 8.5 on both sides, which means that actually we are not getting people's. Now we want to see what if we have 5 volt here, it means that our board is it's getting into SO state. But if we have 0 volt, it means that our board is not getting into SO state. So let's see what do we have here on this inductor. 5 volts. So it makes that our body is actually making its way into SO state. Now we can connect the fan and hope to now see a fan spin. Now you notice there was a slight delay
Exactly.
after the charger was connected. The reason why that is because the charger that you're using it has to go through a form of identification process because it's an original Apple charger. If it was a Chinese charger, that delay process will not take place. It's immediately you connect power to it, the machine is just going to start, which is unhealthy for the machine. So it's always better to use an Apple original charger. Now, that delay that you get is because the charger that we're using is an Apple original charger. If it was a generic charger, there'll be no delay. It's just going to start, which is unhealthy for the board itself. Now we know that the board is starting, and so the next thing we want to do is we want to see if we actually getting something on the screen. Let's put back the Wi-Fi card. We are only going to connect the cables that we need for the testing. So for this, the cables that we need for testing are not more than we will connect the keyboard and trackpad cable. So which is this cable here. So the way the MacBook this particular one is designed is the keyboard plugs into the trackpad, and then the trackpad then connects to the board. Now, if your keyboard is faulty, because it's going to affect the function of your keyboard. If the trackpad is faulty, it will affect the function of your keyboard. Not necessarily because the keyboard connects to the keyboard connects to the trackpad and then connect, but because the keyboard functionality is routed through the trackpad. So the keyboard will communicate through the trackpad. So we connect that cable and then we connect the screen cable as well. We would like to see if we have something on the screen. Now we may now also plug in the IO board cable just to in case you wanna. Also, we can get to now hear the speaker chime as well if that is on. Okay, so also now you will be able to see charger LED as well.
There's gonna be a delay.
Now, yes, there will definitely be a delay. So first it's going to come green and then amber.
There we go.
Yeah. So now you have the charger LED as well. So do we have anything on the screen? Okay, that's it. We want to. Yeah. So we don't really want the device to go to desktop. So I don't know if you can see that. Yeah.
It's fine.
Can you see it? Okay. So device is booting, but we don't want it to boot. So we disconnect it. So a summary, this was a low power and then we had a short on our PP bus. We traced the short, we did a manual isolation. We used the manual isolation method. We removed the fuse wires to differentiate between where the issue is coming from. So here, what we did is flip the board. So what we did was to remove F7140 to identify where the short is coming from. After we removed it, we realized that our short is not coming from this side, but coming from this side. So what we then had to do was to find out the connect where this is connected to. So we found that that is connected to R5450. So we remove R because R5450 connects to more. It's a gateway to more components. We remove R5440. Then we realize that we actually do not have the short on this line, but because of the short we have on the pin 1 of R5440, that is why we have the short, because the R5440 when it's installed becomes equal to whatever is on pin 1 becomes equal to pin 2. So we then from here we now narrow it down, and then we did a visual inspection to check the sections where that line is connected. We didn't find anything here. We came here and then we found that this component here, C7372, was blown. We removed it and replaced it, and then our issue was resolved. And as you guys can see, the device has been tested. This is now going to go through assembly, and that's it. Thank you guys. I will see you guys in the next one.